Hello, everyone, and thank you for joining us today for the show Must Go On, presented by Estructura's panel of speakers and brought to you by IFMA's Corporate Facilities Council. Please be aware that this webinar is being recorded and you are muted to prevent background noise during the presentation. If you have any questions during the presentation, please type them in the questions box. You can find the questions box in the top right of your screen with the speech bubble and the question mark in it. If time permits, the panel will answer your questions at the end of the presentation. I'd also like to make one technology note for this webinar. As you can see, we have a lot of speakers today, and we also have slides. If your slides are not currently large in the middle of your screen, I have a few notes that you can do. First, you can hover over the tile with the slides, press the three dots in the top right corner, and either press full screen or press pin. Again, full screen or pin, and this should make your slides large in the middle of your screen. You can also hover over that middle of your screen and go up or down with your mouse to make the slides larger or smaller. And then also at the very top of your screen where it says active cameras, feel free to change that to hide everyone, and that can also make your slides larger. I now turn you over to the CFC's Programs Committee Chair, Dexter Barra. Thank you.
Thank you, Kylie. And thank everyone for joining our first CFC monthly Wednesday webinar for 2026. What a way to get the year started. We'd just like to take a moment to recognize the CFC Council for winning Council of the Year. And a big congratulations to Jose Diaz for receiving the Emerging Professional of the Year award, which was much deserved. We'd also like to take a moment to thank our sponsors, SenseFix, Estructura, First On Site, Empire Office, and Tersano, who help us to bring this great content to you every month. We'd also like to give a big shout out to Linda Besetsky and Wayne Weitzel for being champions for the CFC. And now I'd like to introduce Will Simon. Will Simon is a Bay native and currently resides in San Francisco with his family. Previously an assistant director of facilities at Stanford University, where he oversaw all operations for their world-class aquatic facility. He later transitioned to the corporate sector, playing a key on-the-ground role in achieving the LEED Platinum status for a new tech headquarters. Currently, he's the Director of Operations at the Palo Alto JCC, where he oversees 12 buildings, a fleet of 16 vans, a preschool, and more than 220 students. In just 2 years as an IFMA professional, he's earned his FMP, earned the Eric Tischel Scholarship toward his SFP, and now serves as the membership chair for the Corporate Facilities Council. He's also the co-chair of the Silicon Valley Chapter Mentorship Program and the founding leader of IFMA's Arenas and Stadiums Networking Group on the IFMA Engage platform, which is what he's going to speak on here today. You have the floor, Will.
Thank you, Dexter. Great to be here. Thank you, everyone, for joining. I wore my Team USA jersey for this because it is Olympic season. It's my favorite time in athletics. So we're just going to jump right into it. So we've all seen how social media is raising the stakes for high ticket sales, sold out events, and our arenas and venues are under more pressure than ever to stand out. And in response, the industry has seen a surge in stadium renovations with mixed use real estate developments and the evolution of cutting edge technology that's designed to intensify the fan experience. So in this fast-paced environment, facility managers, not only do they need to keep up with this new competition of stadiums, but they also need to be able to anticipate what's next. So the arena and stadium operations platform on IFMA Engage was created to build that collaborative community so that we can we can learn from the past and kind of evaluate what's going on now so that we can better shape the future through leadership, teamwork, and more proactive initiatives. The vision of this is to establish a dedicated council that supports professional growth for facility managers by providing strategic resources and guidance and that peer-to-peer support so that we could aim to elevate that experience for everyone who engages with our stadiums. And to kind of bring this vision to life, we're looking to invite industry professionals to lead key discussions on topics that align with IFMA's 11 core competencies. And so the mission here is to create that platform for professionals to push the boundaries of stadium operations through collaboration and action. So in the coming months, we're looking to put out content that's specifically designed for facility managers with insightful articles and interviews, Q&A sessions that really focus on the common operational challenges and how we can use forward-thinking solutions to solve those. So thank you all for being here on this call. Please join us on IFMA Engage as we shape the future of stadium operations together.
Thank you, Will. And we look forward to just learning more about arenas and stadiums. Now, without further ado, I would like to introduce you to the Estructura team. Thank you for being here, gentlemen. Our first person I'm going to introduce here is Fernando Neris, founder and president of Dorado Services and Estructura, and a raving fan of the Orlando Magic, and also a frustrated stand-up comedian. Mr. Edwin Fernandez, business development for Estructura out of the Miami office, former killer star of the Puerto Rico national volleyball team. Talhan Biro, GenSig Director of Sales, Director of Earthquake Engineering, bilingual English and Turkish, and plays lead electric guitar as of 35 years. And Eduardo Criado, Estructura Growth and Risk Advisor, formerly a leading insurance executive on the island of LATAM, and loves the ocean and would love to be a better golfer. So gentlemen, without further ado, we'd love to hear from you this morning.
Yeah, we would like to start by shouting out to one of our founders, professional engineer Julio Miranda, who's undergoing some structural monitoring procedure on his hip. So shout out to Julio, speedy recovery. And like the title says, the show must go on, guys. Estructura as an organization was kind of born very organically out of a need of some of the customers for Dorado Services, a need for public safety and sustainability. It happened in Puerto Rico about 4 or 5 years ago, gentlemen. Again, as a result of the need of the portfolio of customers for Dorado Services needing more sustainability in the monitoring of some of their structures. As Estructura got more traction on the industry, I would like to share with you what I like to call was a water to wine moment, when we actually realized the capability of this technology and how important and critical it is in managing all different types of structures and facilities. And this happened in the first structure that we instrumented in the island of Puerto Rico, which is a Chubb building, which is a big insurance company in North America, and is the actual structure where we have our offices in San Juan. At the time that we had finished the instrumentation of the facility, there was a fire alarm. So the building started to be evacuated. And as the building was evacuated, we received an alert stating that there was a difference in the weight load of the building. We started looking at each other as if, what exactly is going on here? And when we realized what had happened, it was that the system was detecting the weight load change of everybody exiting the building through the central stairwell. So it is that precise and that sensitive that it was able to detect that change in the weight load of the structure as people were exiting doing this fire drill. That was the watershed moment for us, where we realized how important, how critical, and how precise and sensible this technology is, that it needs to be implemented in every facility possible. And with that, in having said that, I will leave the next part to one of our founders, Fernando Neris.
Good morning. Today we want to speak about structural health monitoring. We are platinum partners of Geosig. It's a Swiss company. So this is Swiss technology that's been around for over 30 years. And our role is to provide this structural health monitoring service to you and to complement your consultants with real-time data of your structures, so you can make informed decisions based on data and not just visual inspections. This system is currently available for all of you. We can reach out and consult with you. And let me give you the next video will definitely catch your attention. I don't know if anybody's hearing the noise, the sound, but all right. So now that I have your attention, maybe some of you people recognize some of these venues, and hopefully none of them are yours. But structures are silent to us as humans. But the SHM, the structural health monitoring system that we're presenting to you, will listen to your structure. It'll help us determine the normal wear and tear of your facilities, the aging, and in case if there's any natural disasters or human-made disasters, like earthquakes, hurricanes, tornadoes. Can you imagine a venue that's full and all of a sudden a tornado comes or a hard wind? We can tell you pretty much immediately if you have to evacuate or if your structure is still safe. Can we go to the next one? So I have a couple of analogies for you. So right now you see the planes. Everybody knows that planes are totally monitored and all the data goes to a black box. I mean, they're monitoring wind speed, the engines, all the electronics. Everything's being monitored because they want to be safe. They want to make sure that that plane is going to make it to its destination and that all the passengers will be safe. Can we click the next one? And then automobiles, the same with automobiles. You're driving your car to the grocery store or on a vacation with your family. You want to make sure everything is good. Your tires, your oil temperature, water temperature. You know, these cars are now monitoring everything that's going on. And why do you do that? You want to be safe. And now us humans, we all wear eye watches. We have rings. They detect oxygen levels. They detect stress, your heart rate. Why? Because you want to maintain your health. You want to be healthy and last longer. So what we want to introduce to you is that we do have a way of you monitoring one of your biggest assets, your venues, your buildings, your bridges, dams, and practically any type of infrastructure. So that's what we're presenting here. And then here's a video of our capabilities. Can you guys hear the volume?
No, we can't hear the volume.
Give me 1 second, folks. This is Kylie. Let me see if I can make the sound work. Give me 1 second, please.
Thank you.
Okay, I'm going to try one more time to restart the video and see if the sound works, okay? Let me know.
Delivering modern technology to the Americas and Caribbean that has been used extensively around the world for over 30 years. This technology is a call to action for our aging infrastructure. Estructura has the privilege of being chosen as a platinum partner to the world-renowned GeoSig, a Swiss technology corporation. GeoSig provides structural health monitoring equipment for new and aging structures. From residential to commercial buildings, bridges, dams, railways, government facilities, hospitals, hotels, historical landmarks, mines, airports, nuclear power plants, and scientific equipment across 7 continents and 60 countries. Structural health monitoring utilizes sensors to detect an exceedance of allowed performance while identifying and verifying structural behavior. GeoSig's revolutionary Swiss technology provides immediate response, with each sensor having a minimum sampling rate of 50 samples and calculations per second. You truly get a real-time view of the structure. With such a high sampling rate, the system responds immediately to any changes in the structure. Notifications. Audio and visual alarms can be installed inside a structure for occupants, and email notifications can be sent to management when critical changes in a structure are detected. These urgent notifications can literally save lives. Building integration. Our equipment can be tied into building management systems so that responses to structure change can be customized to turn off at-risk critical services like utilities and elevators, or open electronically locked doors for ease of evacuation. Reduction of repair costs. Early indications of potential damage allows for predictive maintenance versus preventative or reactive maintenance, lowering costs throughout the life of the structure and potentially extending the life of the structure itself. Mapping of multiple properties. Properties with multiple structures like schools, hotels, and residential or business campuses can be monitored on a single system from anywhere in the world. Satellite comms and solar backup. GeoSig equipment and software can protect even the most remote locations via always-on satellite connections and solar power generation. These satellite connections also serve as a backup for critical infrastructures like hospitals when threats like hurricanes and earthquakes are ongoing. Conclusion. As Florida wrestles with mitigation strategies to avoid another building collapse, like Surfside, Estructura's tools provide continuous data on structures subject to the effects of sea level rise, especially in highly salt-prone coastal regions. Even lapses in governmental inspections, or simply the natural passage of time, can play a role in structural safety, so it is imperative that owners and residents utilize every tool available to them. For example, emerging research has noted that electric cars are about 50% heavier than traditional gas-powered models. As electric vehicles become more prevalent, they will pose a direct structural threat to both multi-story and underground parking garages. Estructura provides our clients peace of mind with custom solutions that offer an affordable way for commercial and residential customers to reduce risks, lower costs, avoid disasters, and save lives.
Great. So basically, we wanted to also inform you that we have a collaboration agreement with Terra Intel. Dr. Manu, which is a world-renowned scientist working with subsidence of the soil and the ground. He's got access to satellites that have been up since I believe 2022. They are constantly surveying the entire Earth. So we've been able to consult with him, with our clients, to not only give us a history of how the structure has been behaving, but also the ground around the structure, so that you as an owner or a manager can use this data with your consultant and figure out if the subsidence is part of what's causing the problems with your structure, or if it's not, or if there's something else that we have to look at and help. So we're trying to be a one-stop solution for you as a client to help determine if there's anything wrong with your facilities. So before a disaster, we could give you all the information. During a disaster, let's say if it's an earthquake or hurricane or a tornado, we could tell you if the building or the structure is fine for occupation, or if you have to shut it down. And then after the disaster, we could also help assess with the system. It'll tell the inspectors where to go first. It could triage the facility and let them know where to start the inspection. Not most inspections have to start from scratch. They have to start from zero. They don't know where to go. So our system will tell you exactly where to go and where to start your inspections. And the same with Terra Intel. I can tell you if you had a hurricane or some kind of flood event, if your surrounding property or ground has been affected by that. Next one. And I believe. Yeah, so with the Terra Intel, as you can see here on the slide, we could help you with multiple structures and facilities, and especially stadiums and complexes. At the end, I will show you a case study of the Coliseum here in Puerto Rico, of an actual report that we got from the system and some data and how we used it. And now we'll have the man himself, the creator of this, Dr. Tahan Bira.
Thanks a lot. Thank you, Fred. I'd like to follow up with what has been presented up to now and take the next few minutes to talk about something we rarely think about. What our structures may tell us and how we can listen to them. Before we talk about technology, let me start with who is behind it. Geosic is a Swiss developer and manufacturer of precision measuring solutions with more than 30 years of experience in measuring what most people cannot see: earthquakes, seismic activity, structural behavior, and industrial vibrations. Over 3 decades, we have built systems that operate in some of the world's most demanding environments, such as nuclear power plants, supported by a global partner network. This background matters because what we are about to discuss is not an experiment or a concept. It's a solution that is the result of a long-term experience in critical monitoring, where accuracy, reliability, and credibility are essential. With that foundation, we introduce our solutions, not as gadgets, but as tools that are fit for the job. Continuing with the next slide, let's step outside of the world of arenas or civil structures for a moment and look at aviation. In 1950s, aviation fatality rates were about 5 deaths per million departures. Today, that number is closer to 0.1 per million, a 50-fold improvement. One of the key contributors to this safety revolution is the black box, known as flight data recorder. Why? Because aircraft are never silent. They continuously record data, detect anomalies in real time, and critically provide objective insight after an incident. This data doesn't just explain what happened, it helps prevent the next failure too. So the question becomes, if black boxes transformed aviation safety, why don't we have an equivalent for buildings and structures? Here is the uncomfortable truth. Most civil structures are silent. Unlike aircraft, structures have no black box. When a significant event happens, an earthquake, strong wind, man-made impact, sudden failure due to aging, decisions are often made with no objective data. Assessments can be subjective, slow, and maybe weeks or months. Even worse, many of the dangerous issues may be invisible. Aging, settlement, tilting, stiffness loss, changes in dynamic behavior, all these develop quietly, without alarms, without history, without trends to guide decision-making. No data means no memory. No memory means no learning. And without understanding and learning, we cannot predict or prevent failure. That's why this slide ends with a simple message: listen, then thou shalt learn. This is where GeoSmart comes in. It is designed as a structured black box with real-time alerts, continuously collecting data, continuously analyzing it, and learning from it. It monitors not just one parameter, but a comprehensive set: accelerations, displacements, frequencies, response spectra, rigid body motion, interstellar drift, rotation, tilt, wind, and ambient conditions, name it. All of this data is stored locally or in the cloud, creating a long-term structural memory. On top of that, GeoSmart applies AI-powered entropy and anomaly detection to identify both sudden events and gradual changes. Note that there is an important design philosophy here. GeoSmart delivers simple, intuitive information for ordinary people while preserving complete expert-level data for engineers. This is not about overwhelming users with graphs. It's about making structures understandable. The next question is scalability. It is built to be automated, scalable, and affordable, making structural health monitoring viable, not just for iconic landmarks or buildings, but for every structure, including arenas, stadiums, and large venues. The system produces clear outputs and factual action plans, which is why insurers and regulators increasingly encourage this approach. It doesn't just observe, it can trigger real-world actions: alarms, messages, relays, sirens, open doors, valves, or give remote notifications. In other words, the system doesn't end at data, it connects monitoring directly to operational response. GeoSmart follows on the next slide a simple life cycle: design, deploy, and operate. During design, sensors are strategically placed based on the structure's geometry and characteristics. During deployment, the structure is represented digitally, creating a live 3D reference model. And during operation, the system continuously records, analyzes, and visualizes data in real time. This is not a set and forget system. It becomes part of daily operations, quietly building up intelligence in the background, ready when it's needed the most. Following further, for operators and facility managers, clarity matters more than raw data. GeoSmart's web interface presents information visually and intuitively, with color coding, simple maps, and 3D models. When something happens, the system doesn't just raise an alarm, it delivers a clear action plan. Messages are written in plain languages, alarms are clear-cut. This means faster decisions, reduced uncertainty, and safer outcomes, especially during stressful events when time is critical. For experts, at the same time, does not simplify by hiding information. For engineers and experts, the system provides full access to raw data, waveforms, frequency content, and statistics. Event reports are factual, traceable, and defensible, essential for post-event analysis, regulatory reporting, and insurance discussions. This dual-layer approach ensures that everyone gets exactly the level of information they need without compromise. Moving forward, finally, let's talk about intelligence. GeoSmart uses machine learning, specifically a random forest algorithm, to create a behavioral model of each structure. It learns what normal looks like and detects when behavior changes. It does not follow a single decision tree, but compiles and extracts from a forest of many possible trees. It distinguishes between transient anomalies, like short-term vibration changes, and permanent anomalies, such as shifts in baseline frequencies or, for example, stiffness loss. By analyzing both time-based and frequency-based features, including entropy, which is a measure of disorder, the system moves from simple detection to prediction and prevention. In essence, the structure is no longer silent, it speaks, and GeoSmart listens. Just as aviation became safer by listening to aircraft, our structures and arenas can become safer by listening. GeoSmart is not just monitoring, it's structural memory, intelligence, and accountability. It is smart monitoring. Thank you.
Okay.
Rupi, next in the line is Eduardo.
Okay.
The stage is yours, Eduardo.
Thanks. Thanks, Alain. Yes. Hi, everyone. I'm grateful for your interest in knowing and understanding how innovation is really providing data to make better informed decisions. As an insurance broker, I always focus on what could go wrong and manage that risk from a perspective. Those exposures or even don't derail your mission nor your capital. Today, I will focus on those key drivers that demonstrate the value and return on investment a structural health monitoring system can provide. Number one, predictive maintenance. This will improve the safety and certain the structural integrity. Systems equipped with the structural health monitoring are capable of continuous monitoring, such as early detections of issues. This reduces as well maintenance costs and extends the life of the structure. Number two, mitigation during a disaster. It will allow for automated shutdowns, enhanced building management systems by providing immediate real-time verification of structural behavior, thereby supporting effective emergency evacuation procedures, and ultimately minimizing the costs associated with false evacuation. It's a critical component of any business continuity and resiliency strategies. Number three, what we call post-disaster recovery, can optimize repairs by identifying specific areas of damages, better data to settle the insurance claim. And this drives me to the fourth return on investment driver, the insurance perspective. Okay, the impact of insurance. The number one thing that it does is the underwriting consideration, primarily from the risk profile perspective, and eventually you could get premium discounts. Traditionally, the insurance underwriters assess risk and determine premiums based on factors such as code, construction, occupancy, protection, and exposures. Insurers usually reward policyholders who can mitigate the risk by smart building technologies, those enhancing safety and security, like advanced surveillance, detection, fire prevention systems, are increasingly recognized by insurance for potential premium discount, which could be in the range of 5 to 20%. The other component within the insurance sector would be the claim resolution aspect, providing both parties with real data on what were the structural damage to properly adjust the loss. And number five, property valuation. The assurance of safety provided by SMH systems serve as a valuable attribute for property owners and prospective buyers. Also, the sustainability and resilience that the system provides to the certification of the structure, reducing risk and preventing disasters. So now let's move to the government and regulatory actors that are embracing this kind of technology. Several states and federal agencies have adopted or promoted the structural health monitoring system for critical structures. And certain states are specifically proactive, integrated, innovative monitoring solutions within critical infrastructure, such as bridges, building, railroads, and dams. These leading states have distinguished themselves through the forward-thinking and comprehensive approaches to structural health monitoring, setting benchmark for others to follow. In summary, government entities are increasingly embracing SMN systems for the reasons discussed above, with a central objective of saving lives through enhanced structural safety and risk mitigation. Thanks.
Okay, here I want to give you all a case study, again with a venue here in Puerto Rico, the Coliseum of Puerto Rico. You guys probably know about Bad Bunny. He had the residency here last summer, but we've had the Coliseum wired since I believe 2023. So back in 2024, Bad Bunny ended his world tour in San Juan at this Coliseum. He had a 3-day mini residence. He had concerts there. So what we wanted to do, the management wanted us to analyze how the structure behaved during those concerts, because he was already announcing his residency of about 35 to 40 concerts in a row in about 10 weeks. So we sat down, analyzed the data. As you can see here in the bottom left, one of the concerts, the amount of vibrations and how it behaved was comparable to an earthquake of about 3.7 magnitude. So you can imagine 43.7 magnitude earthquakes happening if that residency was to happen the same way he had that last concert. The same month, right before the Olympics, Puerto Rico hosted a FIBA basketball tournament where the winner qualified for the Olympics. By coincidence, Puerto Rico made it to the finals and we won the finals. So we had the same amount of fans, almost 20,000 in attendance. So you can imagine we're the home, the people hosting the tournament. We won. We made it to the Olympics. That only got to about a 1.7 magnitude earthquake, the amount of vibration and how it behaved. So the management of the Coliseum and Bad Bunny's management saw this data. They did what they needed to do. So now the latest residency, we've just started to analyze the data. The highest that we've seen so far is only a 2.7. So consciously, the management of Bad Bunny and of the Coliseum were able to lower either the decibels of the music and the pyrotechnics to an acceptable level so that the building can last longer. Can we go to the next slide? And then here's a real report that we received. And as Will mentioned, this was, you probably can't see the date on here, but on the very left, you'll see it's blue. And then the date was March 28th of 2025. It was probably about a month before the residency was going to start with Bad Bunny. So we were all kind of alerted that the structure sent us a message. But the good thing is that it was blue. And you can read right under the top left blue, it says no damage is expected, which is great. So what it was showing us is that something happened on the roof. So we went back to the time, we analyzed the data, and we noticed that at the time of this alert, it was raining almost 1 inch per hour, and the winds at the stadium, because we also installed a wind sensor due to hurricanes and different events, the wind was over 55 miles an hour. So the system sent us a warning that the roof had received a change of load, presumably from the rain and from the wind. So we informed the stadium. So what they did is they did maintenance on all the rain gutters. I think they're looking into maybe adding more gutters or making them bigger because, you know, the rain events now, the stadium's already 20 years old. So the data and the requirements back 20 years ago are much different than the rain events we're receiving here in the tropics. So this is a great example of predictive maintenance that our client received, and they were able to make adjustments, and I don't think we've received 1 cent from a rain event. And okay, you can go to the next one, Edwin.
As we come to the end of the presentation, gentlemen, what we're looking to do is to make sure that everybody's very informed and knowing that this technology is available and how it can make a difference to your particular structure. As a matter of reference, we last year we were invited to a summit in Saudi Arabia regarding stadia specifically. And basically, we have all these layers of new technology that are pretty amazing, from managing waste to electric, better usage of the electric grid, so on and so forth, one layer on top of the other, which is magnificent, it's fantastic. Most people don't realize that we now have an option that can monitor everything that these layers are built upon. It's the actual structure itself. So now we can offer the same level of forensic data that can help you with your structures, not just advancing technology, but protecting it as well with our system. And we also like to share with you that the path forward is pretty simple in the sense that all we need from you and your facility are drawings of the actual structure, whether it be architectural, engineer, or elevation drawings. That has no cost effect to you at all. And with those drawings, we can provide a full offer of magnitude. We can provide a formal proposal for your specific structure that will allow you to see the multiple benefits that the system can bring to your specific structure. So with that said, please make sure you send us your inquiries, your drawings, and we'll respond promptly with a specific proposal to your structure. But again, one of the most important things to our organization is to get the message across. Not only that you install our system, but that you know that this technology is available. So please help us with the educational factor, spreading the word that this is available so no tragedy can happen again ever. Thank you.
Thank you, gentlemen. Thank you all for coming today and for giving us this wonderful information that I'm sure that we can all use. Kylie, do we have any questions from our attendees?
No questions yet in the chat, but if you have, actually we just got a compliment. Excellent presentation. Thank you, Maria. But if you have any comments or questions, the questions box is in the top right hand corner of your screen. Feel free to type them there.
Well, I have a few questions. This first one is for Fernando. How important is it to measure the subsidence, and how does Estructura combine it with GeoSig?
Yeah, so the subsidence of the ground, Dr. Manu at the University of Virginia Tech, he made a study that's readily available. He studied 29 major cities around the United States, and practically every single one of them is sinking. New York City, Chicago, Houston, LA, major cities all over the country. And the data was so impressive that we reached out to him to help us do assessments for our clients. And I'm telling you right now, like the Dominican Republic, the Jet Set nightclub that had that major collapse where hundreds of people died, his study showed us from satellite that not only was the roof subsiding down, but that block, that whole neighborhood around there was also sinking, millimeters a year. But that, after 20 years gets to be pretty significant. So his data was able to help the people in the Dominican Republic. We gave them that data for free to help them, start doing their forensic analysis. So yeah, that data, and that helps us as well as with our system. We put tilt meters and accelerometers. If the building is tilting, we could use the satellite data to see if it was the ground or if it was an actual structural fault.
Okay, and thank you very much. My next question is about ROI, right? So as you know, facility managers have to be great stewards of their budget, and we have to go to senior leadership and explain why we want to purchase certain things, right? Can you tell me a little bit about savings, like what the payback is for purchasing this software, the ROI?
Well, let me tell that one of me. Climate change will continue posing a challenge on all structures. And like you heard, and in this presentation, structure is silent. And GeoSig is the way to understand their behavior. Like I mentioned at the beginning of my presentation, the way the insurance companies assess and evaluate the risk, yes, there's a component of two things. What's really going on in the market, the insurance market, and the price volatility that may have. And also on the end, you have the construction cost of the rebuilding those structures. With this kind of system, we definitely will have more data, and we can have better underwriting criteria when it comes to know what's the real structure. Like Fernando mentioned it, the subsidence that was seen. Okay, how much is that going to be affecting in the event of an earthquake, in the event of a hurricane? So we can model that. And based on that modeling, we can just say, you know what, using this information, we can have better data to monitor, and we can have a discount on the premiums moving forward. And lately, the insurance market is going very kind of volatile, and this will give you more data to stabilize that volatility regarding the risk within the structure.
Thank you. Thank you very much. So tell me, if someone installs this in their facility, how does Estructura have to be involved with the day-to-day once the equipment is installed?
Yeah, let me answer that. First, let me explain. It's so easy to install. It's like installing a Wi-Fi system. The sensors are all connected to each other with Cat5 or Cat6 cabling, and it gets power over that Ethernet cable. So for us to install it, we literally do not need permits. It's like installing a Wi-Fi system. So we put them in strategic locations that the structural engineer informs us where they want the sensors to be put in. We wire them up and put them to work. Once the most difficult part is pulling the cable. Once we pull the cable, 3 or 4 days later, the system is running. So that's the ease of it being installed. The question was, what was the other part of the question?
The question was, does Estructura have to be involved in the database, in the day-to-day management of this?
Right. We'll do as much or as little as the client wants. We can simply sell you the equipment, install it, and show you how to run it because it pretty much runs itself. Or we could do the data management, which a lot of our clients want us to do. We manage the data and supply it to their consultant to analyze and to help them make decisions. Or some of them don't have a consultant, so we become their consultant and help them analyze the data and help them make predictive maintenance decisions. And that's another return on the investment is we can help make the longevity of your structure longer, so it'll last longer, finding issues before they become major problems.
My last question is for Dr. Bureau. Can you tell me about some of the advantages of the automated predictive maintenance versus relying on manual inspections, as a lot of properties do today?
Yeah, absolutely. In fact, I can give an example, a little bit different perspective. We can probably all remember the earthquake that happened in Christchurch in New Zealand quite a while ago. And in the most affected areas, there were hundreds of businesses, let alone, of course, residences and everything. But when we are looking from the business perspective, all these businesses had to wait up to 2 years, that an inspector to come over to your property or your business and say, yes, this business can continue its business or not. 2 years. So if you consider a case where you have a arena or another commercial installation, losing time out of missing maintenance or no maintenance and failure, you have to lose the time. So whatever brings the system is that the advantage to make timely decisions. It will help to give a decision based on factual data. The data will say, here is the data, here are your regulations, here are specifications, here are design parameters. According to all these, then you can decide on facts. You don't have to wait for anybody. Of course, you can wait for somebody, but you don't have to. If you have already structural engineers, if you're already structure supervisor, they can already tell you, based on this data, we have to stop, or we can continue.
Thank you. Thank you very much. And I'd just like to thank our entire panel, Dr. Bureau, Edwin, Fernando, and Eduardo for taking the time to speak with us this morning. I have certainly learned quite a bit. At this time, I'd like to thank everyone for coming out this afternoon and this morning for some folks to listen to this content. If you have any questions for the Estructura team, we'll put their information back up here shortly. Kylie, I know you have some information you'd like to share.
Yeah, thank you everybody for attending this webinar. This was phenomenal content. Thank you to the entire Estructura team, not only for being sponsors, but for putting your time and efforts for the members of the CFC. We're so thankful. I have a couple announcements. First off, we are having another CFC webinar next week. We're having our monthly Spanish CFC webinar. I am dropping in the chat the registration link. If you would like to register for that webinar, please feel free. And if you do not speak Spanish, but you're interested in the webinar anyways, still register, and the recording will have an English transcript that goes with it. In addition to that, I wanted to let everybody know that we have a survey that will pop on your screen when I end the webinar, and it will also be sent in your post-webinar email tomorrow. Please fill out that survey to give us feedback on this webinar and let us know what you want to see in the future. We do still have a few spots open for our 2026 lineup, and we'd love to know what content you want. Finally, thank you to Dexter, as always, for being my partner in these webinars. And special thank you to Will Simon for coming to promote the Arenas and Stadiums Council, growing council, networking group, soon to be a council. That's all from me. Dexter, did you have anything else you'd like to share?
I just like to finish that the show must go on, and so please reach out to Estructura so your show can go on. All right. So thank you, gentlemen. Thank you very much for being with us today.
Thank
Thank
you.
you.
Take care.
Thank you.
Gracias.
Bye-bye now.
Thank you.
Bye.